All right. So let's see what we got here. This is the same page we were working on yesterday or not?
Yeah, it is.
Because I can't read anything at the top. I assume we've done all of those?
Yeah.
So where are we beginning here?
Number 3.
Can't even read the numbers. What is it in relationship to those 4 tables that I'm looking at? Is it above that? Must be. That must be question 4. I can't read number 3. You can see why. It's completely blurry.
No, number 3 is on the other page.
Okay. You want me to open up the other page?
Yeah.
Let's try that. Ah, yes it does. Okay, now I get it. Let me see if I can blow that up one. Yeah, now it's allowing me to blow it up without it switching to landscape mode.
Yeah.
All right. So we've got 2 ski lifts and the distance in meters that you travel after some number of seconds. Which ski lift is faster? Okay. How would you determine which ski lift is faster?
Well, by the slope.
That's not bad, but what's a better way?
By the steepness of the slope.
Well, how about we take a fixed time, like for 4 seconds, and see which one has gone further. Notice that here, let me get so I can write on this thing. Notice that if I take 5 seconds right here, see where I'm pointing? Does that count on your end or mine?
It counts on, wait, what'd you?
I'm hearing a cat meow, and I don't know if it's my cat.
My cat's right next to me.
Okay, that's fine. I just wanted to make sure it wasn't on my end. I can't tell the difference. So, okay, so if we take 5 seconds and the 2-person chairlift, how far does it go?
It would go, shoot. I remember this. I know this.
You're not calculating anything. What you're doing is reading the graph, and you're looking over at the vertical axis. That tells you what the distance that it goes.
It would go 10 meters.
Okay. So if the 4-person chairlift in the same exact 5 seconds goes how far?
12 meters.
Which one's faster?
The 4-person.
Always. So that answers A. Now, you actually came up with a very interesting solution that the slope is what matters. In other words, the steeper the slope, the faster it is. Because notice what speed is. Speed is meters divided by seconds.
Yeah.
It's the vertical measurement divided by the horizontal measurement. That's also slope.
Yeah.
In other words, the vertical motion is the distance between there and there, the time that it takes, the distance between there and there. That's exactly the definition of slope. So you're absolutely correct that everything, you could answer that question merely by looking at the slopes and not doing the measurements like we did.
Yeah.
I can't read your explanation, but that's okay. You understand the problem. I'm not big on word answers anyway.
Yeah, I understand the problem.
Okay, so 3B. a 3-person lift travels at a speed slower than the 4-person lift, but faster than the 2-person lift. Draw a line alongside the other graphs that might represent the distance. Well, I see 3 lines there. So obviously the middle one is that line. In other words, this line right here, see it?
Yeah.
That's the 3-person lift. Notice what it says. It travels slower than the 4-person lift, so it has to have a slope less than the 4-person, but it has to have a slope greater than the 2-person. And that's somewhere in between. It doesn't have to be exactly halfway, but it has to be between those 2 other straight lines.
Yeah.
Okay, and that's that problem. So now we're going to the other page.
Yeah.
There was nothing else on there, was there? No.
No.
Okay, so this page here. Well, I would love to know what happened to my computer. All of a sudden, I can blow this thing up.
My teacher told me that part D is probably, I don't know which one it was. It was part D. Not part D. Yeah, part D was the hardest, I'm pretty sure is what he said.
Okay, well, we don't necessarily want to work on the hardest. A lot of times that's self-defeating. I take it that that top problem is number 4?
Yeah.
And I can't read any of that. So either you need to take another picture and hold the camera directly over that part of the paper and send it, because what it looks like is that maybe you were at an angle and you got clarity in the middle of the page and the bottom of the page, but you didn't get good resolution at the top of the page on your photograph.
We could just move on to part D. I understand. Or we can move on to the tables. I understand the top one.
I can't even see what they're asking about in the tables. In other words, everything, all of the instructions for the tables are above it. Go ahead and tell me, what are they asking for in those tables?
So they're asking which table represents 4 points on line S. Explain your answer.
And that line is at the top of the page?
Yeah.
Okay. Let's go on to D. And if we run out of time, I'll have you take a picture of the top half of this page and resend it to me. In fact, you should do that anyway. We want to talk about these. That one. Okay.
How do I do that? I don't.
What's that?
I don't know how to send stuff like that.
You don't know how to take a picture with your camera and send it?
Well, like, not really.
Okay. Your mom's been doing that?
Yeah.
Okay. And I suppose she's not around, huh?
No.
Okay. Well, let's go to part 5 or part D and try to answer this one. All right, write an equation that could represent line S. Well, I got one problem. Which is line S?
Oh, it's part of part 4.
All right.
Just got 5.
Oh, I get it. Okay. So the very first question has to do with the line above it, but 5 and below have to do with these lines we can see. Right?
Yeah.
Okay. I got it. Okay, so lines A and B have the same slope. How do we know that? What do you notice about lines? You know which is line A and which is line B. how could you tell they would have the same slope even if they didn't tell you that? Two lines that have the same slope are parallel, always.
Oh, yeah.
In other words, that's a set of train tracks. You could go to infinity and they would never intersect. And that's exactly what parallel means, is they have the same slope, or same slope means parallel.
Yeah.
Okay. So the equation of line B is y equal x. Let's write that. Line A passes through the point 0, 2. Let's put that on there.
Yeah.
Never be afraid to mark up your pictures here. That's the way you get to the bottom of the thing. What is the equation of line A? Okay. There's two ways to do this. One is with a vertical shift. The other is with a horizontal shift.
Yeah.
Both of them give you the same answer.
Yeah.
So, yeah, the answer's staring right at you. In other words, if I'm going to take line B and move it up 2 units, I would do it like that.
Yeah.
If I was going to take line B and move it to the left 2 units, I would do it exactly the same way.
I don't understand. Wait, what?
Yeah, no, I get why that's confusing, and I hate the fact that they are using straight lines to explain this, because it is very confusing and it doesn't need to be. So, let's take this function. I can explain this process better if I don't have a straight line. We'll get back to this problem. But if you're trying to understand how these translations work, we got to have a function like this.
Yeah.
Okay? That's that function. Standard parabola, notice where the vertex is. It's at the origin, 0, 0. It opens up. Okay?
Yeah.
Now, let's suppose that I wanted to make this parabola go 3 units to the right with the same exact shape, so that that vertex is now at 3, 0. Well, the way I would write that would be in the form of x minus 3 quantity squared, where the adjustment takes place inside the parentheses. You with me?
Yeah.
And it's in the form x minus h. So h is a positive 3, which means it shows up as x minus 3.
Yeah.
Now, let's say instead I wanted to take my pink line and move it up to here. Forget the blue line. Well, now I'm writing that as y equals x squared plus 3.
Okay.
And notice the difference. The difference is the x squared, the plus 3, is outside the function, whereas on the blue line, the 3 is inside the function.
Okay, so since
that tells you whether it is horizontal or vertical, always.
this green line is out of like the area of the function,
The green one, yes, that plus 3 is a vertical shift.
Okay.
Here's the way you want to remember them. All horizontal shifts, let's use this function, and let's just go through a few. I don't know how else to explain this. Explaining it on that is ridiculous because it's a straight line and nobody understands why a horizontal shift looks exactly the same like a vertical shift. Well, that doesn't happen with a parabola as your parent function. Okay?
Yeah.
So here's the deal. If I have this, that is a horizontal translation by h units.
Okay.
Hold on. That is a horizontal squeeze by a factor of 2.
What's a horizontal squeeze?
It's where this parabola would look like this instead. In other words, it makes it skinnier.
Oh, okay.
It's like pressing in on the sides.
Okay.
We've changed the shape. They haven't given you this yet?
No.
Well, I don't want to use our whole session teaching you this then. We'll just go back to their straight line and answer that question and then go on. This is very important stuff, but I don't want to get you doing stuff that you're not going to do until Algebra 2. And some of that stuff is Algebra 2 stuff. So let's go back to this. I'll explain this the best I can possibly do it. Okay, the equation of line B is y equal x. That is that line. Notice that it is in the form of y equal mx plus b.
Yeah, I
It's
see
just
that.
that b is 0, right? It goes through the y-intercept at 0.
Yeah.
Okay, so, and it's also, m is 1. The slope is 1. I got to go up 1 unit and over 1 unit. I got to go up 1 unit and to the right 1 unit. So it really is in this form, y equal mx plus b. It's just that m is 1 and b is 0. So you end up with that equation.
Uh-huh.
Okay. Now, there is 2 ways to think about equation or line A. The simplest way to think about line A is you take line B and you move it up 2 units. You move the whole line up. Correct?
Yeah.
These 2 units that are between that and that goes from 0 to 2. Well, that is a vertical shift, so I add 2. And that's all you need to know for the moment.
Yeah.
Now, is that the equation of line A? Well, what's the slope of line A? We know the slope is also 1 because it says it's got the same slope as line B. So that 1 in front of the x is correct. And what's its y-intercept? 2.
Yeah.
So it's in the format y equal mx plus b, only its b is 2.
Uh-huh.
So that's all you need to do for problem 5.
Okay.
Let me scroll down here so I can get problem 6 more in the picture. Okay. Okay. Write an equation for the blue machine. Well, what's the general format for our equations?
Is y equals mx plus b?
Okay. Tell me what b is on that line, on the blue
B
machine.
is the y-intercept and m is the slope.
Yeah, but where is the y-intercept on that graph of the blue machine?
The y-intercept is vertical. It's 196. It's 96.
Hold on.
196.
Hold on. The y-intercept means where the straight line crosses the y-axis.
Oh, that's at 192 and 12.
Hold on. Isn't it right there at 0?
Oh, yeah.
Okay. So B is 0. So again, we get y equal mx. Don't need to include the b. It's 0. Okay, this is the wrong equation right there. Now, what's the slope?
Uh,
How far? Take a point. Okay, we know this point here is 0, comma 0, right?
yeah.
Well, this point right there is 6, comma 96. Figure out the slope between those two.
Well, I know 96 goes into 60.
Hold on. Slope is rise over run.
Yeah, sorry.
What's the rise?
The rise is 96.
And what's the run?
I can't see it. It's a pink.
It's 6. In other words, the run is from here to here, and that is 6 units. Okay? Or 6 hours, I guess. This is in hours.
Yeah.
Okay? So, our slope is 16. 96 divided by 6.
I'm
In
pretty
other words,
sure.
the definition of slope is 96 minus 0, all divided by 6 minus 0. So all I'm doing is y sub 2 minus y sub 1 divided by x sub 2 minus x sub 1. Remember, that's what slope is. Okay? And I'm using these 2 points. I'm using that point and that point. I'm using the bottom one because that's really easy. That's 0, 0. So I don't have to do much math here. 96 minus 0 is 96. So it's 96 divided by 6. That's 16.
Okay.
So the equation of the blue machine is this.
Okay. Understand.
Now, they didn't graph the equation of the red machine, but they gave us its equation, and we want to graph it. Why not?
Yeah.
Well, the only difference between the two machines, they both start at 0. They haven't made any widgets when the time is time 0. But the red machine has a slightly different slope. It's just a little bit flatter. So which machine is faster?
The blue machine.
Yeah. Which machine is faster is the blue. I think this is a typo. At no place in this question does it ask you what the equation of the red machine is. Now, it's perhaps because they give it to you. I don't know. But you got the blue machine is y equals 16x. The red machine is y equals 15x. We've already figured out that faster means steeper slope.
Yeah.
So blue is the faster machine. Explain the reasoning. The only thing you have to say is it has a steeper slope. It's got a slope of 16 versus a slope of 15. How long will it take each machine to make 240 widgets?
I said 18 and a half hours, but I think that's wrong.
Well, I don't know if it's right or wrong, but I want to know your reasoning.
Well, I divided. I don't remember.
When they say 240 widgets, which axis are they talking about? They're talking about the horizontal one or the vertical one?
The horizontal one.
No.
No, the vertical one. Sorry, I got
This is
horizontal.
number of widgets. Well, it's actually their fault because they didn't label it. But that vertical is number of widgets. This horizontal axis is in time, in hours. Okay? So once you label the two axes, now we know this is the y-axis. This is we can call it the x-axis even though it's in time. We'll call it the x-axis. So they're asking you, what is x when y is 240? So for this one right here, I'm going to plug in 240 for y. That's the number of widgets. That's equal to 16x. Use your calculator, figure out what x is. 240 divided by 16.
Where's my phone? Oh, right here a minute ago.
Well, plus your answer was based on the wrong formula. It was based on this formula here, which isn't right.
Yeah.
The two formulas that concern us are this one and this one. We don't need any graphs at all to answer this question. So, do you have your calculator?
No, I can't find it. I had it a minute ago.
240 divided by 16 equals 15. In other words, if I go to 15 hours, which is right here, I am going to produce that amount of widgets, which is 240 right there.
Yeah.
Do it graphically or I can do it algebraically. Algebraically is the simplest way to do it. I could have made a mistake graphically. I could have misread this number over here. It doesn't say 240 over there. So if I want an exact answer, I've got to do it algebraically.
Yeah.
I've got to start with y equals 16x. And what is y? Y is the number of widgets you produce. They're saying when is that equal to that? Now you solve that for x and you get 15 hours. So the first machine, the blue machine, takes 15 hours. Now, how do I get how long it would take the red machine to do it? Here's the equation of the red machine.
It'll take him 15.
Give me the equation. Solve it as a math problem, not as a verbal problem.
I equals.
No, it's not y. What are you going to plug in for y?
240.
Yeah, y is the number of widgets you're making. That's what y means. So in this case, it's 240 equal 15x. And if I use my calculator for that, I get 16. So this one, the blue machine, takes 15 hours, and the red machine takes 16 hours. Well, we knew that the blue machine was faster, so that makes sense, that it would produce 240 widgets in a smaller period of time. But the whole thing can be done algebraically. Once you come up with that equation right there, based on reading the graph, figuring out the slope and the y-intercept, give you this equation. You don't even need to figure that one out. Then you can answer all these questions.
Okay, I understand.
All right. What next? I think that's the only 2 pages I have. Want to do a little practice on the flashcards?
Sure. Is this for an hour?
It's supposed to be. Uh-huh. Doesn't have to be. It's up to you, but she scheduled it for an hour.
Oh, okay. Well, let's do that.
All right. To at least do a little bit of practice. Just because you need this practice really a lot. I want to see improvement is what I want to see. And the only way you're going to show me improvement is if you practice it on your own. Do you have it on that computer?
Yeah.
Okay. So,
4.
show me some improvement. Good. And I'm glad you don't have your calculator anymore. I don't want you using your calculator.
-5.
Good.
-24.
Good.
7.
Always remember that when you take a bigger number and you subtract it from a smaller number, it can't be 7. In other words, if 9 minus 2 is 7, then 2 minus 9 has to be -7. It's the exact same number. It's just a different sign. And the only thing that determines whether it's positive or negative is whether the first number is bigger or smaller than the second number.
Yeah, I understand.
Okay.
+2.
Good.
0. 9. 5.
Have you been practicing?
Yeah.
I can tell. You haven't made a mistake yet.
Oh, -10. 4. -4.
Sign first.
Positive.
Answer second.
72.
Yep. Wow, you had a world of difference there. Now you know the process on how to do these. I can see that. You know it 100%. Now the only reason you need to keep practicing is so that you'll memorize the results. In other words, what is 4 times 7? That's just something you have to memorize. And you can memorize it by just doing it repeatedly.
-20.
Negative what?
-28.
28, yeah. Okay.
I already know it's a positive.
Good.
+36.
Good.
8.
You know what? You're fine. Do this one, and I'll let you go.
0 times -8. 0.
Yes. Anything times 0 is 0. Always. Okay. I'm impressed, Jackson. You showed me a lot of improvement here. And you're out of problems, and so we'll just call this a 40-minute session. Okay?
Okay.
Sorry, that was on my end.
Okay.
All right. Have a good one. I'll talk to you next time.
Bye.
Bye-bye.